Hi everyone, my name is Joelle Chia. I'm a PhD student in the Department of Aerospace Engineering, about 1.5 years through my PhD since I started. So very happy to be here today to introduce you to a part of my research for my PhD, which is to map spatial-temporal aircraft operational and environmental data as a step towards a corrosion digital twin. So just to give you a little bit of background about my research motivation, in aviation, aircraft are typically made of metallic structures. And with metallic structures, it is prone to corrosion, especially if it's being operated in areas where it's more corrosive, for example, industrial areas or close to the sea where there are marine salts. With corrosion, here comes safety concerns. So this incident here happened about almost 40 years ago, but even in relatively recent years, in 2019, there was also a similar event where the aircraft broke halfway through the flight, which led to a fatal incident. And that was because of corrosion leading to premature fatigue failure of the aircraft structures. So some people may argue that it's not more than a handful of such incidents, but what about the everyday cost of maintaining an aircraft with corrosion as the silent killer? So in aviation, aircraft designers and manufacturers tend to take a more conservative approach. So for example, they would say, keep washing the aircraft, keep doing your inspections, keep doing your maintenance, repair the aircraft when corrosion is found. And all that makes sense, but it's adding on to the cost that operators have to painfully take if, which they don't have to if corrosion can be predicted and implemented only when necessary. So with all that saga about aircraft corrosion and the concerns around that, I formulated a research objective to develop a unified airframe digital twin for predictive corrosion maintenance. So I already have tons of spatial-temporal aircraft operational and environmental data that is related to corrosion. I also am building a corrosion prediction model. Now my research question is, how can I deploy the model and all this data into an airframe digital twin? All right, the approach that I'm taking is to first build a software application that can store this enormous amount of data, and then also incorporate the corrosion prediction model into the software's backend, then develop visualizations for this output, and finally incorporate a feedback system such that users can input inspection findings, and that would update the model and keep this as a living digital twin. So when I started to propose my idea for this demonstrator showcase, the idea was to develop a high-level digital twin as a preliminary proof of concept. So this is from scratch. Before this showcase, nothing was done. It's just, we just had ideas and tons of data. So it's a step towards a digital twin. Note that it's not really a live digital twin right now, but it's a base that we can continue to build on towards. And with that, we also want to define exactly what is a digital twin. So according to Greaves and Vickers, who are one of the pioneers in the realm of digital twin, they say that a digital twin is a set of virtual information that describes an actual physical product, for example, an aircraft, across various scales, such that any information that can be obtained by inspecting the aircraft can also be obtained from the virtual representation. And when we started off with this project with in this demonstrator showcase, first we had to outline the requirements based on my idea of this digital twin that I want for airframe corrosion prediction. As I mentioned, it's starting from scratch. So we just want to focus on building a base model, something that I can continue to build up on in the later part of my PhD candidature. So for now, we just focus on this version 1 here. So part of the most important requirement is to have this option of time window scrubbing, which is where users can define the time window that they are interested in. Because as I mentioned, we have enormous amount of data, and it's not possible for the users to look at all that enormous amount of data. So we just want to show the user what they are interested in. I also want to be able to display the information of the environmental and operational parameters, as well as the outputs of the corrosion prediction model for the user to understand, to have a quick glance and look at what they see from the time period that they are interested in looking at. And then for visualizations, we also have want to have trajectory lines to show the relative aircraft movement on the map. And since we are interested in more on the values or the output of the corrosion prediction model for this digital twin, I want to have a color code of the representation to have a quick glance and show what is the higher values of outputs of predicted corrosion, what are the lower values. And obviously we'll be more concerned with the part where it shows a higher predicted amount of, or a higher predicted risk of corrosion. So what is shown here is a screenshot of the product that was developed. And then up here on the top right corner, this is where I have the option for users to define the start time, to define the end time. And then once that is selected, all these icons will be plotted out onto the map. There is also an option to select a specific date if the user knows exactly what time, what date they want to look at, and then you can click directly to zoom into that location. On the map, there's an option for to change the type of visual layout, what kind of base maps that the user prefers to look at. So for example, this one is a map from OpenStreetMap, but if the user prefers to look at something like Google Maps, that can be changed as well. Here is the legend to show the color mapping of the outputs of the corrosion prediction model, which is reflected on the plots that all these icons, they are essentially the aircraft position at a certain time. And then we have an interactive time series corrosion prediction model. So this is linked to the corrosion prediction model that I brought to this project. And it's interactive in the sense that you can zoom in, you can zoom out, you can pan around, you can overlay your mouse to look at the details. And same goes for the map. It's also interactive, so you can pan around, you can zoom in. You can also click on each of these icons. Each icon is clickable, so when you click on the icon, it opens up a pop-up box which shows the user all the parameters that they would be concerned with. So for example, I can see what the airspeed is at that particular time. I can see the temperature. I can also see the exact value of the predicted corrosivity value. Oh, it's working now. So when we start the program, nothing appears on the map. And then after defining the start time and end time, we click on Show Aircraft, and that's where all the plots of that period of interest will be shown. You can shift around the map, you can zoom in, you can zoom out. And also on the left there, we have a table of this aircraft information. So in this case, we are assuming a fleet of 3 aircraft. And these are all real aircraft. It's from the RMIT Aviation Academy fleet. And then right down there on the right, that's where the interactive time series plot is. You can zoom in. to a certain time period to look at the values. So these are all arbitrary values right now, but it's linked to that corrosion prediction model that I was talking about. And then now if we are interested in looking at a specific time, you can select the specific date, specific time. And when you click on zoom to location, that's when the map will zoom in to that particular location where the aircraft is at that particular time. And the pop-up box will automatically appear such that you can see all the information, all the parameters that you'll be interested to know about. Now, in summary, so this was done in collaboration with RaceHub through this demonstrator showcase project. So before this project, what I had was just ideas and data. Like I mentioned, this project was all done from scratch over this past 2 months. And with the technical expertise from RaceHub, with Pat's help, Mohammed's help, we were able to identify the appropriate tool to use for visualization for spatial mapping using a JavaScript library called Leaflet. So Leaflet is able to host this map onto a web application. And what's nice about Leaflet with it being a web application is that you don't need to download additional softwares. It's lightweight. You can have certain customizations. For example, over there just now on the screenshot on the right, I had the data about the aircraft information. And I also can plot in the interactive time series plot in there. So customizations is a big part of what I was expecting out of this project, because I believe this kind of airframe corrosion digital twin is something that has never been done before. So a lot of customizations are required in terms of the user interfaces, the functionalities. So now coming back to what defines a digital twin. I believe the demonstrator that we have built as a base model, as a prototype, meets the requirement of showcasing virtual information, and also reflects the same data from inspecting the aircraft. Moving forward, more work needs to be done on multi-scaling. So that's more on, like, for example, the putting in a CAD model of the aircraft itself to be able to know where on the aircraft are we getting the corrosion hotspots and at what particular date time that is. So the impact of this project is going back to my research motivation. We can, through this digital twin, aircraft maintainer can use this digital twin to be able to quickly tell where did the aircraft go, what kind of corrosion they are going to look at, what are the risks of corrosion, and how they can further plan their the movement or the scheduling of their fleet moving forward. So that's all I have for this presentation, but I want to have a shout out to Pat and Mohammed for helping me with this project, and thank you very much.